trust is built not by making the system more confident, but by making it more honest about what it isn't.
Great. So today we want to talk about AI and ethics. And today we have Ant Newman, Shanti, and myself, Piyanka Jain here. So yeah, let's dive right in. What's top of mind for you all as you think about ethics and trust and human trust, on users' trust, on AI systems that are being sold to people, that are being built internally? Raz?
I've been looking at some of the recent polling that shows that basically nobody trusts AI. More than 50% of people don't like it, which I find unbelievable. I think it's a great technology. And it's interesting to see that that's the general public's reception of this, which is, I don't like it, I don't trust it, it can do too much. So I'm kind of curious, did that surprise you guys as well?
Not at all. I think the starting point there is most people look at it as almost binary. You know, their example of AI is, I tried AI and it was bad, or I tried AI and it was good. But, you know, as we're about to discuss today, I'm sure, just because you've used AI doesn't mean it was a good or bad example. It's just, you know, it's so varied. And we're going to probably speak about how you can build trust with it, right?
Yeah, I think to say. Go ahead, Shanti.
Yeah, and I was going to think, and early on, it was pretty bad. I mean, it was not doing the tasks it thought it could do. It would hallucinate all the time. So yeah, it was pretty bad, but now it's pretty good.
Depending on the use case, there's still a fair bit of hallucination and there's still a fair bit of drift. Like you ask the question one time and then you ask the second, third time, it is like different answers. And drift in the system creates distrust. I think trust, when we can't trust something, it's hard for people to use it with confidence. So I think trust impacts usage and confidence. And so if we want people to use it, we are all builders and users and we're building solutions with it. But if we want general public to use a system which is AI native or AI, then we need to somehow create trust in it. Otherwise, there's always this doubt or wrinkle in my head, like, I don't know whether I can trust this completely. And that just kind of discourages usage.
And I think even the way we talk, the way we work in demos and pilots as well, always think pilots, it's your, thanks, Piyanka. Pilots is your, your ceiling of what you can do. Whereas in production, you're really caring about your P99, or in my case, P99.99, because for the listeners, we do live sports broadcasting, auto subtitles, and moving into auto dubbing. So, you know, it works fine when you do all your examples, but the one thing you really care about, it's where the goal is being scored. And the voices are never like they've been before because the commentator's suddenly so excited he's squeaking and the cheering is louder than ever. And you're in these unique cases that these edge cases you haven't tested. And that's when everyone's watching as well. So it's you've really, really got to train for your floor and not your ceiling, and have trust at the floor. Doesn't matter how fancy it is if it goes wrong in that one moment.
Yeah, and that's a really good point, that those edge cases, which don't show up much in our training data, we don't see them frequently enough, but that's where a lot of the judgment happens because there's some importance there. So those get overweighted and sometimes you never have them and you don't see them. And it's really hard to know that that's going to be the moment you need to test against. And then when it fails that test, it becomes a huge problem.
When you are training, have you tried any kind of treating statistical disagreement as a signal? Kind of outlier as hard escalation. So have you tried any of that yet?
Yeah. So sometimes what we'll do is we'll try to basically hand code in these corner cases, things that probably won't show up, but we know would be problematic if they did. So we try to insert those, or we'll oversample from some of those edge cases.
Yeah, and I think you're bringing up a very important point. And for your production system, the specific one you're talking about, where you are translating into many, many languages real time with a latency of X seconds, or maybe it's milliseconds, I don't know, not this
sub-second.
Right? That's a crazy system where you absolutely, those are the the gold moments or the photograph moments that you need to capture right. For systems like the ones for example, I'm building on Enola, we need to solve for 95% of the case, which is falling within 2 standard deviation. It's like, if you ask about distribution of product, if you ask about root cause analysis, if you ask about forecasting revenue or forecasting, we are almost not that worried about those edge cases because it usually is like 10 clicks down. It's not going to show up in your first N clicks. And so in that, like, Enola is an AI analyst. And so in an analyst case, can we get it to a human level? Because humans also err. If we can get our agent to be in human level analysis, that's good enough. But that's not going to be the case for Teslas, which are driving around and meet something like it's dusk, the sun is shining a certain angle, and there is rain or whatever else happens together. That's a use case where Tesla needs to really manage more versus less. So, yeah, I think it's AI as applied to use cases and built to purpose to figure out what you're building for and what level of trust is needed.
Yeah, and Piyanka, one of the interesting things about like some of those analytics use cases is often that comparison is made to humans. Like, oh, we're doing this with human analysts now, but we need your AI system to be 100% accurate. We have no room for error there. And I hear that frequently, and I go, but your humans are not 100% accurate. So not only do I have to build a system, I have to build it to a better standard than currently exists, because we think the humans are at this certain level, but they're sometimes doing things in like Excel spreadsheets. Well, those are notoriously difficult to actually QA and check because the formulas are hidden and the way they throw errors is really done quite poorly. So how do you try to get that extra level of certainty in what is currently an uncertain system where people refuse to accept that it's uncertain?
I think there's actually another, thanks, Shanti. I think there's another stage to it as well. Actually, sort of when it comes out of the AI system to the human, it used to be the bottleneck used to be how much data you can get to the person, right? And we've always gone for right data at the right time to the right person or now agent to make the right decision. But now we have so much data, and even when you do get this system and people are happy with it, often people want a human in the loop, which that's a separate conversation about when and when it shouldn't be there. But let's say there is a human in the loop. Now they're being inundated by this data stream and they're treating every decision equally and they're not triaging it. So you can actually end up with, they can end up with some recent studies showing that with these systems, there's so much they're getting overwhelmed and they're missing what they would have previously caught. So they're actually making it worse, but not because of the system's wrong, but because of how they're interacting with it. And that's part of trust as well. It's understanding that when we're talking to a CTO or someone on our board, we are seeing the whole picture and not just the technological. But obviously I had that killer phrase by accident when we were chatting before. What was it? Trust is built not by making the system more confident, but by making it more honest about what it isn't, right? So
yeah, when it lies confidently, it's a problem. Just lie.
That's right.
Like lie less confidently. When you're lying and you're almost not certain, tell me your confidence interval or your confidence level.
Yeah, I like to add that to my system prompting when I'm like, if I'm asking for an opinion or for research, I'll say things like, and if you don't find evidence to support this, report back that you didn't find evidence to support this. I was trying to build basically a fact-checking application because I really wanted to be able to go to any website I'm on. Sometimes you'll see a whole bunch of claims and be like, I'd like to click a button and just fact check all of those claims. I don't believe those now. So I built a quick thing to do that. And that was one of the things I was thinking about during the fact checking is some of these claims you won't be able to find any evidence for. I need the system to report back that I can't find evidence for this. Not, yes, I've got it, or no, I don't have it. I need to just know, like, couldn't find evidence.
Yeah, that's a good point. And actually in this world, in the green room, we were talking a little bit about when executives are buying AI solutions, and you know how there's logos and there's testimonials, which are completely these days, because it's very easy to make them. So I just instructed, I was for Riverside, where we are recording this, I was changing because we have now moved, we have separated Airing from Ask Enola. They're two companies now. And so I just wanted my email to go to Piyanka at askenola.ai. And the Riverside people are saying, we need this document from you stating this. Took me 2 minutes of prompting to get that exact document. Didn't have to do anything. No manual stuff. Signed by you. Of course, I instructed the LLM. Create my sign. Create a logo. 2 minutes. I upload it, and that seems to have worked. But so easy. It's so easy to do that. If I could do that, anybody can create the same airing, Askinola, whatever logo they decide to do. I'm giving people ideas here. But anyhow, the point being that it's so easy to make fake stuff, or so easy to make stuff which previously was not easy to make, that it's very hard for executives who are not building hands-on, or even people who are building hands-on. How do we figure out what can we trust? I know, Shanti, you have built this system that basically goes and looks at logos and says, give me proof if there is any, or do you at least tell me that this is true? What else can executives do when they look at AI systems? Either it's internal system that they are building that, people are trying to find trust on it, or external systems that you're looking to buy. What are the ways in which you can find trust in these systems?
I think also we should say at this point, I think I mentioned to you, Piyanka, OpenAI just bought PromptFoo, which was doing about 25% of all of them like validation on for the S&P 500 companies. So now it's like vertical integration, right? OpenAI, are they really going to be telling you when their models aren't? So it's got even harder. So it's even more. I'm just saying this is more prescient. Brief segue to basically say, well, everyone listening should go, this is difficult.
It's getting muddier. What you just said is getting muddier.
Yeah. I think part of it is the cost of evaluation needs to be factored in, because sometimes you just need to use the thing to see if it will perform in your particular circumstances. Like a lot of the sales pitches, they set up the ideal scenario with the ideal data, and it will work and do something that it's supposed to in those situations, but that may not match what you're doing as a company. And sometimes that first week of just testing something and putting it through its paces is really all you need to do to understand, will this work? Now, depending on what your data security policies look like and whether you're going to pass your data through other places, I think there's definitely some nuance there. One of the things that I look at if I'm evaluating vendors are questions like, well, can I deploy this in my ecosystem and then do whatever I want with it for a week? And if they're like, no, you have to go through our SaaS platform, like, I don't know that I want to do that. You haven't earned that trust yet, because if we're passing enterprise data through your platform, I need to already know that you've established some level of trust. And a bunch of companies are startups now. You look at so many companies and it's 3 people. They've barely done anything yet, but it's so easy to build software that, like, if you have a good idea, you can build that software and you can be on the market with a shiny, fancy looking website. It used to be like you could look at somebody's website and be like, they haven't put much into this. Now you can have a fancy website, all of the things matching very quickly, and you can have reasonably well-produced software that will at least pass the sniff tests. So then the question becomes, well, what does it really do?
So for my company, we're not that much bigger than what you describe, but I spent like 45 minutes on the website on day one, and I haven't really touched it since. But what I do is, to build trust, is I provide local models so they can run them locally. So we don't have any of their data. They can see the functionality slower, unless they've got the capacity to run it. We give instruction how to run it, but we allow them to test it in their environment so they can see the functionality. And if that's no risk to them, there is no data risk. So
exactly, yeah, I think that's a great way to do it. Which is like, here you go, here's the container, put it where you want, do however you need to do. Come back to me in a week and let me know if it worked for you. I think just that confidence, when you can hand somebody a working application for them to put in their environment and use however they see fit, that builds trust right there. Just knowing that you can do that.
To do that. And I have a contrarian view to your container thing, especially because I'm coming from Enola, which is a really agentic structure. It is also containerized. But the other way to at least trust our system is to do a subset of a data, strip it of any PII, and set up a connection. Your SaaS connection is encrypted. Your connection between the two systems are encrypted, but it's also data which is stripped of PII. So there is that easy, quick testing, a week or two, that can be done. On the other side, I have a little bit of pushback on the container thing, because what protects my IP, which is pretty significant, if I were to ship a container to you, because it's pretty much anything can be, as long as like PyArmor, whatever else, it can be reverse engineered. So it's pretty much not protected at all. And if I am selling to 100 people, I'm not selling to, let's say, Walmart. If I was selling to Walmart, no problem. Take my container, do whatever with it, because you're not about to unravel it or try to find the IP in it. But if it's a 20 people company, it's a $100 million company, you can easily unravel. You have the compute. You can run it on your own. You can replicate, and you can that's your system versus there's no need for you to play licensing. So that's the pushback I have, which is not every system is protected if it is containerized, especially when sold when the company it's sold to is not as large.
Oh, I wouldn't even be worried about the code. I would say if you explain your idea in significant detail to technical architects, we'll probably replicate 85 to 90% of it in the first week, if that was a thing that they wanted to do. That's how easy it is and how good agentic coding has gotten.
I agree.
That the barrier to replicating other people's software products is pretty darn low now. I think as a business, you just decide that that's not the business you want to be in. Most people, at least most companies, shouldn't be in the business of building and maintaining software when there's options out there that do exactly what they need to do.
Yes and no. And I will say there's one aspect which I want to talk about. Maybe it's relevant to this conversation, maybe it's not. But the only moat people have now is heuristics, right? Because as you said, software can be built. If it can be done by LLM, it can be done by any LLM, you, me, anybody else, right? So the only moat or only thing which is differentiating is somebody's know-how, somebody's subject matter expertise, somebody's heuristics of if this, then do this, which is how we have control for hallucination as well as drift. That's the only reason Enola can give deeply contextual answer, does not drift, does not hallucinate. That's the only reason, is not because we are doing things the way other people have done. We've not done it that way. We have a lot of if then else, a lot of heuristics, which is the IP, essentially. It's not the code base. It's actually those if then else that we have put in, which makes it as robust as that. And that is like IP exposure, which like companies like me or we are, I don't think we can do or we want to do at this point. But the alternative to that is give us something clean, give your BigQuery clean, whatever, your clean room. We'll connect to your clean room or your PII, PII snuff data so that you can get. But testing is very important. I think that TLDR here is test it for a week or two before you pay a single dime. Essentially, we all agree to that.
Yeah, absolutely. And for a lot of companies, I think their moat, at least what they see it as, is the actual data for whatever customers they already have, whatever they've been doing, and the data they've collected there becomes their most valuable asset, especially if you're talking about companies that do things like lease cameras, or in the subtitle game, I'm guessing it's the actual audio streams where you have modules that change and the pitch changes and all of those different things in different languages, which lets one company like yours actually train and fine tune to those different nuances so that you can say, when a goal is scored and somebody's yelling goal, that's one word.
So I think that's probably not that hard to replicate, probably going back to your first point earlier, Shanti. I would say there's a couple of things which are a little bit less representative of what we're doing. So when we give the sample, they're really doing a QA test on the stuff. They're not actually doing it on live. So they're not getting they don't have the Piyanka, they don't have the full secret source there. So, and then if they're happy with the quality, we'll do a live demo with them. But they'll get to play around with the highlights cutter. But that's easy to replicate as other people do that. So, that's not really the secret sauce. And then I think there's a couple of things here. Without my awesome co-founder, Mel Walker, who's like a big time director, and her connections and her know-how combined with my background, I don't think the product exists. So there's a very unique combination there. And she opens doorways for us, which, you know, it's quite a closed environment. They're very suspicious of all us technology people trying to come in. You need someone who speaks that language, but that can be replicated. And I think when it comes down to the milliseconds, most people out there aren't optimizing like I haven't. Like, I spent over a decade doing military research, and thankfully a lot of us on AI on supercomputers like 20 years ago. And I think another moat I have is that people I worked with can't talk about what we did. So there are some things we can use, and no one can talk about it. So that's really good. That's a protection as well. So yeah, there's a few, but it's like a bit like with I'd say a bit like with confidence in an AI, trust in an AI system. It's not a single feature. It's kind of a human emergent property of a kind of defense in depth architecture, which, you know, in a human sense, and trust in the system is in the system architecture. I think it's not a single feature.
I think what I'm getting out of the gist of it from a user perspective. So we were all talking from a builder perspective in a way, but from a user perspective, of somebody who's acquiring these products, getting a unpaid. Don't pay until you've tested it in whatever way you can. If you get a sample model to run on your own environment, or if you can create something which is stripped of PII and provide that as an input and play with it, I think that creates validity. I think it also creates validity to have actually go back to the old times and take 2 reference calls, go and talk to 2 customers who have used the product. There's nothing, especially if the partner that you're buying from, they are suggesting that they already have customers. Talking to those 2 customers will give you a lot more than So going back to the human way of doing business. Yes, you sell silk. Okay, sold to how long does your merchandise last, or whatever else, how permanent they are. So anyway, that I think those 2 are good ways to think about it. What about internal systems? When you're building it internally, your CTO, your development ops team just created this system which is now able to actually look at whatever your process is and is able to make it faster and able to maybe it's risk escalation, maybe it is sales team's performance which is automated, or whatever else. How do you assess that internal systems are good and you can trust it?
I think you have to speak in their language, right? So you can't go technical straight away, but you have to be able to express technical concepts. So I would explain. So Piyanka, you said earlier on that you're going for like a 95% confidence. So let's say I'm explaining to the CTO, yes, you have a 95 in this, not your company, but in this fictitious scenario, there's a 95% confidence. I'm trying to explain why in this case it's not valid. So I would say most confidence scoring systems are averaging their outputs. I would say averaging hides the thing that matters. So if a model is 95% confident about 9 fields and 20% about 1, a simple average is giving you 87% overall, and you miss the field that's wrong. And so, but then I would say what I'm introducing to get rid of this is we weight the system with confidence inversely. So the less sure the model is about something, the more that the uncertainty drags down the overall score. So a single low confidence field pulls down harder than a high confidence field lifts. So you'd have a deliberately conservative architecture there. So the design principle would be surface your weakest point.
And you are like 5 levels deep already in this. As you're describing it, you're talking about the nuance that you would eventually get to. If I could bring it a little bit up already, like the first level, your people are building systems. Let's say I'm an executive and not technical, and my developers have built this system and they're like this, let's take it to production. How does a non-technical executive find confidence that this is the go forward, or what's the path for that?
Yeah, so Piyanka, one of the things that I've talked to internal teams about a lot is that the development timeline has really shifted from you spend 6 months developing and a month testing to get it to market to it takes weeks to a month to develop, but you need to spend months testing now because you're testing, does the logic of the thing you're trying to actually have solved, like, did you solve the right problem? And then does the software work as intended? And then what happens in the corner cases? And you can solve for all of those things with AI built software if you think about them well and architect it well, but you still need to do that testing. So a lot of it is that shifting your development efforts to more time spent testing and making code more documented and more reliable so that anybody can go in there and read what's happening, what's supposed to be happening, adding in even like more unit testing around things like, well, does this specific module actually work? Does it do the thing it's supposed to do? And then all of the like general testing that happens
such a
in the
big
process.
point, Shanti, that, we used to have a reverse of it, right? Like you build because you're building by purpose, you're doing it step by step. Now you build black box. You have no clue how you have built it because it's all LLM generated mostly. And then you're like, okay, will it work in this? Will it work in that? With the unit, in a very thorough unit testing. And so the testing time has to be, just because you built it in 6 weeks doesn't mean, or 6 days, doesn't mean you test for one day and gone, because it's a testing for days or weeks, which will reveal like, oh, actually didn't even consider this case or that case, and many, many, many cases. So it's an iterative build versus build and test even, right? Because it's not every time you test, you will find 10 things. Then you add to it, to your prompt, initial prompt or whatever else. And then test again, build, test again, build. So really test to build for a while before it actually, solves your problem that you started with.
Yeah. And something that's interesting in this vibe coded world is that actually fixing code is a very strange process now, because if what you're going to do is describe the problem and not describe how to fix it, things will get fixed-ish, but you may end up touching things you shouldn't be touching. And now something else has broken. And there's a possibility that that's going to happen every single cycle you go through. One of the things that I think about and try to do as we're establishing better practices in building software products is going, well, what if rather than saying fix the code, I'm fixing my PRD. I'm fixing the requirements for the product and how it should work. And at some point, we're just going to tear it all down and rebuild it. Because that timing, once you have a good description, you're talking about less than a day. And then you go through your testing process, but you're doing that by actually refining your descriptions and refining your testing as opposed to refining the actual code.
We built our first version of our website with V0. First, looks beautiful, absolutely amazing. Patched it on the website, looks great. Now we have to make changes, and the developers are going, oh, who the hell writes this kind of code? And now it's like, no, I refuse to go edit this code written by LLM because it's like, it's very hard to edit. It's not the most optimal. Developers, we don't write code that way when you write as a human. And then at that point, you're like, okay, are we going to do the rebuild with V0 itself and go send it? Or that nuance you can't get to with V0. So like you really build from scratch, and then you do Claude Code Connect, where you're basically building within the code itself with pieces and modules versus building with something like V0 where it's completely black box. So black box is problematic because you just...
I was going to say, I find I trained Claude on a lot of my best code, my best examples. And in this situation, do this. And it took a long time. So Shanti was alluding to, or directly saying, it used to be MVP, right? You want to get to MVP. Now you want to spend loads of time actually speccing out your final destination almost. And and before that, I've realized it was okay. But before that, I was like, okay, but but every time there's a little problem, which is taking me ages to fix. And in the end, last summer, I think it was about 4 months where I was just spending a few hours a day setting up Claude code. Yep. Literally, like, just, this is my best, this in this situation, this unit test, this test here, do this there. And now it's much better. But cautionary tale, I had a friend a medical doctor who always had this dream, never quite had the finances because the kids went to private school and then the money always kept getting eaten. Big family holiday, but finally could, vibe coding can actually do his dream business. And and I talked him through it. He was serious. He did the idea. He got, 2 weeks, he got to 80% of the way there. Then he spent another 9 months getting to 100% of the way there and said to me, hey, can you test it? I know he did it properly. He really did. It did very well. And hey, can you test it? And within about 20 minutes, I found several security vulnerabilities. So I just posted, locked out, paid Bitcoin to his wallet, and terrified him. Because he had customer data.
Yeah.
Yeah. I mean, he needed to be scared, right? Because he's got customer data on there. He's going to remain very nameless for the world. I fixed it for him. Don't worry, guys. If anyone knows me and they're looking for him, he's not on my LinkedIn. You won't find him.
For the curious, nosy kinds.
Yeah.
Oh, yeah. That's such a true story, that not knowing that black box system. Yes, you can wipe code yourself to anything these days, but there is that what you don't know is what you don't know. And the vulnerability, especially if you've not really, I think one way we get around it is when we build one system, then we build another system to just test it, then another system to question it. So you're building multiple systems to basically arrive at either the same solution or poke holes on it, or I have an example. Shanti, we talked about this in one of the podcasts last time. I got conned by a founder who, I'm thinking I'm an AI, whatever, expert, and I shouldn't get conned, but I got conned. They had such a sophisticated, they were like a clay competitor, but they were much better because they are microsignals. They were going to unearth microsignals for us. We were already going to build something like this. I'm like, oh, this is already built. Why won't I pay for it? And so this is a POC. And it turns out beyond first level, they have nothing. They don't even have current capability of clay in that. But the website is fantastic. And the guy himself is just so erudite and, talks very nicely, polite, blah, blah, very charming. But there's nothing beyond first level of click. So I figured that out in 1 week. I said, well, this doesn't work really. And my team was wasting a lot of time every day meetings. So we asked for a refund, and he very nicely said, no refund. We have a policy and a refund. That's when I realized, the guy is not even interested in why his product failed. He's not even curious. He's just saying no refund because this is what a con man does. It gets you into this. And then it became to me, it was I spent $1,000, but I was really pissed about it. So I said, I'm going to fight for it. So I took all the snapshot, everything, my WhatsApp chat, constant calling, and fed it into Perplexity and said, you act like a lawyer. Create a case for me. We're going to fight this. And we did a fair bit of fighting, but I didn't have to spend 40 hours. I spent half an hour because I had LLM, my sidekick, and I created a case and I won it. I just found out today. Yes. So I feel really good.
Oh, nice. Yeah. Good job, AI.
I feel really good. But there is this whole aspect of not knowing at all what's out there. So there are founders with good intent who are building stuff which doesn't work. And there are also these bad players which are out there because they can do it now.
Yep.
So I think there's all of that is what we are traversing, and which is the overload in our mind, and trust is so important. One last thing I do want to talk about is ethics. Which I kind of slowly slid into it with these bad players and well-intentioned founders. And then specifically AI, which is bias system because it is built on systems that it knows, right? Obviously, if you ask for show me a picture of a dentist, they won't show you a brown or a black person, black doctor, women in there because that's not an average probability, right? So there's a lot of, this was a very obvious bias, but there's biases there. And then there's the aspect of how do we build ethics within it? So your thoughts?
Yeah. Since you brought up that example, do you remember, I think it was spring 2024 when Gemini went too far and you couldn't specify a white scientist. It was no, I won't do that. It was just and they were just you know what, we're just not going to generate realistic looking people anymore. And Gemini stopped generating images for like a solid 6 months because they were so concerned about that particular problem. They're like, we don't know what to do. So they're just like, we're just not going to do this for a while. And that just blew my mind that that's the direction that they had gone, was like, okay, we're so scared of getting it wrong that we'll just stop because the tool was a good tool.
So one thing we haven't mentioned for ethics is explainability.
Forget that.
Right.
That we crossed
And
off.
like it's I mean, what's the use of RAG mainly nowadays? It's trying to explain to the lawyers, trying to give it a reference point where it's come from or something like that, right? It's as context windows get bigger and bigger.
Yeah, but what happens inside the perceptron, nobody knows. Nobody knows, right? So
well, there was a leaky ReLU that said 1, and then we passed that on to the next node.
Exactly. Yeah, I don't think so. And do you have a perspective? Like, do you think? I think we're way past explainability. I don't think we can get explainability. You can get use case and results as a map, as a general direction of a map of a product, but.
Yeah, cryptographic audit will just prove what the system did, but not whether it was correct, right? And, But formal verification provides mathematical proof, but only for like really small systems, like too small to be used at frontier scale. It's no way of. I don't know an answer that solves it. I'm afraid, Piyanka. No. Otherwise, this would be a viral podcast.
There's some super cool visualization of like what's happening inside an LLM and basically all of the weights and connections between words and how that gets passed from one head and then averaging across like for multi-head attention. But even then, and even knowing that and seeing the visualization, like you can't visualize all of the words at once to even get the probabilities. And at some point you say like, well, there's 3 things of equal probability here. So we picked this one. Why? Well, we told it to randomly choose between the 3 when they were at the same probability level for which like token came next. So there's some of that built in as well.
I guess if you're layering your architecture where each layer is compensating for the failure modes of the others, you get to a pretty good place.
Yeah.
Right. It's just whether or not you don't, and then the ethical argument comes in is whether or not you need it. When I talk about, with a US aviation client, we've got like a regional operator who are effectively a tech incubator for nationals. So they were saying, well, I was saying, you're building this for nationals. We need to know their readiness for deploying agentic AI. One, what kind of systems they're using, and 2, what the requirements are in place, because not every one wants or needs. I mean, obviously, aviation, you're getting to depending on what use it is in with aviation, you might be extremely high barrier of efficacy and understanding. So broadly, think in major projects and schedule, but schedule can be things like scheduling staff rotas, which is it doesn't matter about gets it wrong occasionally because they phone up and complain and they sort it out. And actually, it reduces the. At the minute, Sharon's getting her timetable for the next month, like 1 or 2 days before the month starts, and she doesn't know where she's going to be. So she's an aircrew. That's obvious. So that's why I was like, "There's got to be a better way." Through to full-on schedule for the major projects. So then it starts to get more critical, and then it's scheduled for getting into the airspace areas where there's formal things, and then so the level of understanding and certainty you need changes it's basically different versions of the same thing, but it's a completely different verification and trust required at each level. So at the very top level, I've got deterministic guardrails that are providing sort of a hard floor, but they're quite brittle to scenarios, and and then because rule writing might not anticipate something, so then I'm having to develop loads of scenarios and generate those, and then we've got some conformal predictions, and we've got all the different things, but we've got all, and I think that comes to trust as well. When you are speaking to your CTO, whoever, being able to demonstrate you're doing things so that the product is more reliable, then demonstrating to them so you can show, because explaining in some way, even if it's not fully explaining, as we've just touched on, but it feels like it's being explained, even if it's not in the black box, that builds trust with a human being. We know mathematically it's not being explained, but it feels like it's being explained.
Yeah.
So that builds a lot of trust as well. It kind of sounds like I'm saying we should just selectively hide certain truths from the people we tell.
Well, I think we should
God.
just address,
Well,
sorry
you know-
not to speak over you, Shanti, but I think we should, in all honesty, do address the elephant in the room, that there's no explainability. I mean, I usually start with like elephant in the room. There is no way we can explain what it does, right? But having said that, what you were saying, Ant, is like creating an architecture diagram or creating, Shanti, you were talking about visuals. I don't know that visual will create anything. That'll be fancy, like weights are going here and a neural network. It looks fancy, but I don't know if it is. But to the extent that we can actually prove it in some of the use cases and explain why it works, generally speaking, the way it works, and then still have human in the loop somewhere where it is critical so that it doesn't blow up in our faces, that I think will probably create more.
So,
yeah, and there's a couple of different pieces there. One is like if you kind of rely on tool calling, you can trace back the decision tree to say, hey, this was the set of things it was thinking about doing, and it said to do this, I use this tool. And as long as you then trust the tool, you can kind of move that chain down to, well, maybe that tool is deterministic, so I'm okay with it choosing this tool in this scenario. Feel pretty good about it. It will get you to the ethical problem, which has been a problem for a while, which is, and it was a traditional ML problem. Are you okay with decisions being made that look similar to the decisions in your training data? And if you're okay with that, then your system can be ethically sound, for lack of a better term. But if you think that your training data doesn't represent the reality of the decision-making criteria today, you're going to have a big problem. And I think that's sort of one of those existential problems that data science has always faced, which is your model, whether it's a large language model, whether it's a forecasting model, is as good as your training data. And you can selectively choose your training data and bias your training data in different ways. But are you at the core level okay saying whatever we decide will look like this?
Well,
Go ahead.
Shanti, I was going to say, Shanti, I'll call back to you what you said at the beginning. You said people are expecting this AI product to be 100%, but the human's only X% accurate. If it's more,
Icing on the cake,
then it's good enough, right? And I would say that if I can, I think as long one key, if anyone wants to, one key takeaway, if you make your agent what they're doing as narrow and small as possible, but still functional. Oh, okay. That's a really big, that makes a massive, it just makes it a lot easier.
I'm a big believer in that. Yeah, your agents should try to get it to do one thing well and not 10 things kind of okay.
100%.
Yeah.
But you can easily get, like, I can get my, I can get it going wrong, something going wrong one time in 10,000 or one time in 100,000 or one time in 1,000, depending on what I'm optimizing for and what you need.
Right. And also,
and you have got that choice.
You need to be deliberate about it versus randomly surprising you. Going back to your statement, Shanti, this is a very important point of biases which are already existing in your training data. So, for example, when we built the 7-Eleven, the ATMs there, and this is, I'm going back to machine learning AI, like traditional AI, CNN, where we are building a sort of like a forecaster to how much cash to load, but we are using empirical or historical data where actually the ATM ran out of money, $0. It went to $0. So when we are forecasting how much cash will this ATM need, and it has gone out of cash, OOC, many, many times, it's actually taking that $0. And so we had to come up with ways of imputing and actually dirtying the training data to come up with a version 1. But the model improved over a period of time because we reduced OOC over a period of time. So it started improving because the input training data it was machine learning and an optimized linear programming on top of it. It started improving over a period of time. But at the onset of it, you had to agree to dirty the training data itself because you knew those zeros are going to be a problem. And it's going to do undercutting, under budgeting for it. But that's an old problem. That's our numerical problem. That's a problem we've sat in that for a long time. The AI, the Gen AI, what is now called just traditional AI, Gen AI biases. Again, it's a new problem because it's not a problem of numeric values which are certain. It's a problem of biases which are stored in words, right? Like there is certain percentage of people of certain race going through a certain path in your node, or certain conversations that are only always getting routed to Philippines, or whatever that bias is. Those are hard to. Those are hard.
I mean, if you look at how the current language models are biased, they are very biased towards English language and the type of text you can find on the internet. That's just where they are currently biased. And that makes them respond in certain ways to certain types of questions. It's in the data, and the companies sit around trying to take some of that out sometimes or program around it, which you can do. But it's a fact of how they're trained and what you're going to see. You just have to decide, are you okay with that? I don't think most people actually understand that that's where models come from and how they're developed, that they're not magic, because they can do so much that they really do look like magic if you aren't part of the ecosystem of technology and think about them a lot. You're like, I don't know, I tell it a thing, I get code out and working software at the end.
Yeah.
That's pretty darn magical.
And this brings us to training data, because then the only way around that is creating artificial training data, which doesn't have those biases, which is a whole topic by itself. One day, we should talk about that. Well, that's where you decide, but then you've got your software developer or whoever, your data scientist, deciding what they want the ideal world to look like and going like, my ideal world is this. Yeah, this is how the model shall respond.
Oh, you haven't met Jonah. He'd make a lovely world.
Exactly.
Well, it's a wrap from my end. This is great talking about this, and we'll see you all next time. Thank you for listening and wasting another half an hour of your time.